Okay, so based on questions that you guys have asked, let's go ahead and make review of the concepts. And let's go ahead and use the book because they have a pretty good section here. So 2.2, section 2.2, there's a section about how to compute the components of the vectors. And this is very important that we're clear about how to do this because this is the basic concept that we will need to create. Okay, so let's do another section here. Review F components. All right, so as we know, a vector. Okay, let's go ahead and do. All right, so the first thing we know is that a vector needs to be declared, or yeah, declared is a good word, in a space. So in this case, we're going to simplify to 2 dimensions, but if it's 2 dimensions only, it's because the third dimension is going to be 0. So the component in Z is 0. X and Y are my 2 dimensions, and my force exists somewhere. The easiest case is where the force exists in the origin of my coordinate system. That's the easiest case because the tail of the vector is 0. Okay? Now, if they give me a force vector, that force vector has 2 components. The component Fy and the component of force and x. So remember, the total magnitude, the total force, is the square root of Fx squared plus the component of Fy squared. So if it's only one vector, that is the component. All right, and in this case, we do have to add them up. So that number plus this number and the square root of that, just like a triangle. This is going to be 90 degrees. If they give us the angle, we know how to get the components. Fx equals sine of the angle, and Fy equals sine. Whoa, sorry. Wow, I was going way too fast. Fx is cosine of the angle, and Fy equals sine of the angle. All right, so make sure you know how to do this part, and obviously we have to multiply by the force. So let's go ahead and fix this a little bit better. I was going to multiply at the end, but it's convention to have it at the beginning. So F times F is the hypotenuse. This is the main force. Fx, Fy. All right, so this number goes here. That number goes here. All right, so if we don't have the angle, we have to find it. How do we find it? With actual distances. So if this is a distances are going to be with red. Say this distance is 3 meters, and that distance is 4 meters, then this distance is 5 meters. Okay, so that distance of F, let's say distance F equals square root of the distance x squared plus square root of the distance y. So if this is 3, this is square root of 3 squared 9 plus 4 squared 16 equals square root of 25 equals 5 meters. All right, so if we need the angle, it's pretty easy. We know how to do that part. So we know that, okay, let's say we didn't have, well, no, we have everything. So it's pretty easy. We can use whatever distances we we can use cosine, we can use sine, or we can use tangent of theta equals y over x, 4 meters divided by 3 meters, and then theta equals tangent inverse of 4/3. All right, so, whoops, 0.75. 0.25 is 1. Actually, that's not true. I'm thinking of 3/4. 4/3 is bigger than 1, so let's go ahead and compute that number. So what is 4 divided by 3? 1.33. So tangent inverse of 1.33. Okay, so let's go ahead and do tangent inverse. Remember the hat. Well, we're gonna have to do parentheses because it's -1 of, or yes, alpha knows what I want. Okay, how much is this? Is 92. Y divided by x, tangent inverse is 53.13 degrees. Okay, theta equals 53.13 degrees. Then, if we want to find the angle of, wait, sorry, if we want 3, 2, 1, go. If we want to confirm that this 53.13 is true, then we can just use that angle to compute anything else. So let's say we want to use the angle to compute the distance dx, which is this distance. So what we do is the x is the hypotenuse 5 meters times cosine of the angle 53.13. Very nice. So what we do there is go to the math, the calculator. So 5 times cosine of 53.13. Okay, so it's 3. There you go. We're correct. The angle is correct. But if you press enter, I want to show you something here. Be careful because he's going to think that you didn't mean that, since he gave you the result intuitively, that that the Wolfram Alpha computer or kernel thinks that you're computing, and you typed enter, and then you get something else, -4.80. But that is because he's thinking that you mean radians. But we don't mean radians, we mean degrees. So if you want degrees, to make sure, just type degrees, because the symbolic calculator of Wolfram Alpha is that smart. There you go. So it's 3.0000. So this indeed is 3 meters. All right, and then the other angle up there. So if we have a triangle where this is 90, this is 53.13, then this angle, let's say alpha, is 90 minus 53.13. Okay, so 90 minus 53.13 is 36.87. So that angle is 36.87. All right, so that is fully defined, the distances, the angles, and the forces. So that is pretty much how you go around finding the distances and the forces. So don't confuse your meters with your newtons. This part is for forces. The part right here, these computations are for distances. All right, so let's go to the book and see what else they mean. So we know how to compute that. Okay, another thing, if the coordinate axis was defined like that, like the picture, if the coordinate axis was defined like this, and they're giving you a force, and they're asking you to compute the Fx and Fy components, then the only thing you have to do is this same thing. Don't get confused by the orientation of the coordinate system. It would be completely different if they ask you, which is not part of this class, to rotate the coordinate system to horizontal and vertical positions. That's not part of this class. That is with the cosine of that angle, and it's completely different. You have to do rotations, and it's not going to be asked to do that. So just compute. I'm going to even get rid of that new coordinate system because I don't want you to see it on the PDF. Just make sure that you compute just the same thing. Don't worry about that part anymore. That is not looking horizontal and vertical. Just compute with respect to the axis, I and j. Okay, and do the same thing, cosine of theta and sine of theta. Okay, so we know how to do this part by now. Is definitely the components of x and y. We know that the force has components of x and y, and this same thing I usually put it like this: F equals Fx and I, comma Fy and j. Okay, so I and j are the magnitude, they have magnitude 1, they have magnitude of only 1 because they're the unit vectors. Okay, so we know how to do this part. If it's going towards the negative side of x and y, then your components in x are going to be negative and your components in y will be positive. If it's going to the third quadrant, remember this is the first, well, maybe I just need to write it down. In an xy plane, this is your first quadrant, second quadrant, third quadrant, fourth quadrant. Here, x and y are positive. Here x is negative, but y is positive. Here x and y are negative, and here y is negative. Well, x is positive, but y is negative. Okay, so remember, depending if this is my coordinate system in the middle, then that's where we are going to have it. Hence, the component in the x direction is going to be negative. The component of the y direction is going to be positive. And when you get your force, so if this force was like this, the Fx was equal to negative 655 newtons, Fy equals 455 newtons. They're asking you to get the total force. Let me see, it was given? Yeah, it was given. But let's say that it wasn't given. And you need to get the total force. It's going to be square root of Fx negative 655 squared, which that will make it positive, plus 495, no, 459 squared. So that is the same thing as saying square root of squared plus this thing squared, and these values are negative 655 and 459, correct? Yes, 459. That is 861. What are we getting here? 600. Well, let me see. What are we doing wrong? I put the wrong number. 459. Yes. 459. Okay, 799, 800. Perfect. All right, and the x component is negative 609 comes, comma, what is 459j in y. All right, so these are the x and y components. The total force was 800 newtons. So the total force is bigger than the components. If you have the components being larger, either your computer or your calculator is not using degrees, is using radians, or you're doing something wrong. You put in extra things in the calculator. Okay, so this is a good example right here. They're giving you the distances. So with 8 and 6, you can find the hypotenuse of this triangle. And they're asking you to find x and y. So x is positive, but y is negative. We did an example just like this. We know how to add the components. If they give you 3 forces and they're asking you to compute the components of x and y, of the force in x and y, you have to have the same. So if you have 3 forces, you have to have 3 components in x and 3 components in y, no matter if one of them is 0. So if the vector, so for instance, let's keep drawing here. So let's say they give us origin, x, y, 3 forces, 1, 2, 3, 4. Let's do 4. F1, F2, F3, F4. Okay, so you're gonna have 4 components. So let's do here Fx, Fy, F1, F2, F3, F4. So in F1, you're gonna have 0. Whoops, the other way around. And Fx for y, you're gonna have 0. And F1 for x, you're gonna have the magnitude. So if this is just 100 newtons, then you're gonna have 100 newtons right here because there's no angle. Well, yeah, the angle is 0. And cosine of 0 is 1. So 100 times cosine of 0 will give you 100. F2, then there's here 45 degrees, let's say. So here you're gonna have, and this is 200. So you're gonna have 200 cosine of 45, and the same thing here, but with sine. 200 sine of 45. F3 has 0 component in x, and it's gonna be, let's say this is 300 newtons. So 300 newtons. And F4, let's say this is 45, it's gonna be negative, and this value was 400. 400. Oh, but here's interesting. So if they give you the angle here, well, it's the same, but you need to be careful which angle they give you. In this case, it would be the same, but if you do that, then it would be cosine of the angle that you need to compute. This will not give you, cosine here will not give you the component x, will give you the component in y. So what you can do is subtract and get this angle to make sure it's with respect to x, to get cosine of 45. And here you're gonna have positive 400 sine of 45. Okay, you just compute those numbers and get the total force. So here you just have to sum whatever that is, 100 plus cosine of 45 minus 400 cosine 45, and then the same thing here, whatever that is. And if they're asking you for a total force, a total resultant, it will be this number and that number squared. We've done this before. It's always plus because it's a Pythagoras theorem. So this is the resultant over the total force. Fx squared plus Fy squared. All right, like so. Yeah, they're showing you very well. So this is the same. This right here will be 0 in x and negative 110 in y. This one right here will be cosine of 15. This one will be cosine of 30 because it's the angle that is with respect to x. This one right here, you can find that 90 minus 20 is 70, and then you can do it with respect to the x-axis. Okay, and that's exactly what they're doing, except for they're just using that axis is sine of 20 because it's going in the x direction. So if you're getting confused, just subtract 90 minus 20 and get this angle, just like we did. And they're doing the same thing, the table, and then you can compute, well, if they're asking you just for the resultant force in terms of x and y, this is it. If you're asking for a magnitude, then you do square root of each component. It's find the angle is tangent alpha of y over x. We did that too. And obviously it's going to be tangent inverse. And that is the angle of the resultant force. Okay, what does that angle mean? So if you find the total force and they say the resultant is, what is it? 199.6. 199.6. Which they could have done here x and y total. Okay, they could have done these components here squared, 199.91, like so. 199.19. Is it 19 or 91? Yeah, 0.91. And the other one is 14.3. All right, so we get 200. All right, 199.6. Okay, so yeah, they're pretty close. Okay, 200, 199. So that is close enough for any answer that we get. So what that means is that there's a resultant force with 200 newtons. We have to go and try to draw that. So let's say this was well, I don't want to be confusing anybody here, so let me go ahead and just get rid of all that. Is there an easier way to erase everything? Okay. All right, let's just bring that picture over here. So we're not saying that 400 sine of 45 is a value that is not the same. So either we computed those numbers or just bring this example over. I think it's easier to bring the example over. All right, so let's borrow that image from the book and copy and paste. All right, so when we computed, we created a table, we did everything that we needed to, and then we said that resultant force was square root of fx squared plus fy squared. All right, and that was exactly this. Equals 200. Okay. I'm trying to move that. Okay. All right. This is equal to close to 200 newtons. And then we said that tangent inverse of fx, of fy divided by fx, because remember r is equal to fx I comma fyj. So tangent inverse of xy divided by fx tells us, I didn't compute it, but we can go to the book and see that they did, and they got 4.1 degrees. 4.1 degrees. Okay, so what does this mean? So whatever this value gives you is the resultant force is going to be x, y, and all these forces are producing a resultant force with the value of the magnitude of 200 newtons and the angle of 4.1 degrees. which I'm exaggerating. This is more like 45 degrees. If we were going to actually draw it to scale, it would be more like this. 200 newtons, and this is 4.1 degrees. And you can say that that could be true because, well, I don't know what the values are. Let's see. Those values are going to be much bigger than if the ones going to the left-hand side. Yeah, because this is 100, this is 150, and this one is only 80, and this one pulling down is 110, so it's pretty big. So you can see why it makes sense to think that the force resultant is going to be towards that, to the right-hand side.